Moving on to one of the most important part of the lesson, that is relationship between EV and R, that is relationship between EMF, potential difference and internal resistance. There are two methods. First method is this method, which is kinda the important one. So work done now from electromotive force. This is the formula of electromotive force. We take dq here, we get a second formula. We substitute the value of dq. Now we all know that current is equal to charge upon time, so charge is equal to current into time. We substitute the value of dq and we get a new formula. Now we're going to calculate two types of work. First, external work, and second, internal work. External work is equal to V into dq, same formula. Just instead of EMF, we're just taking potential difference, not much difference. Substitute value of dq, we'll get IDT. This is the external work done. The values are given here, so you can actually understand what is what. Moving on to the internal work. Now internal work is V into dq. Now if you notice, here there is small v, here there is capital V, here there is small v. Small v is actually equal to I into small r. So dq would be converted into IDT and small v would be converted into I into small r, thus giving us internal work as I square r dt. Now, according to the law of conservation of energy, total work done is the external work plus the internal work. Our external work is equal to VIDT and the internal work is equal to I square IDT. And dW, if we had remember, we had calculated value of dW as IEIDT. We will now cancel out the common terms, that is IDT, IDT and again IDT, thus getting us a new formula where V is equal to I minus R. Refer this for what each symbol belongs to. Now if I want to find the current with respect to this, we all know according to Ohm's law, current is equal to potential upon resistance. Value of potential I substitute here, I'll get this. I'll take this to this side, find out the common factor and get my I as E upon R plus R. Refer this box for further explanation. Now the second method, which is kind of an easier method but not the preferred method. Now we know our total resistance. We'll take total resistance as capital R plus small r, and I is equal to V upon R. Now we can assume potential difference as EMF, thus we can take E as V and we can take total resistance as R plus R. Ta-da! We've already got this formula which we had got here. And if I want to find this, I'll take this value here, I'll multiply both the sides and I will get the same formula, that is V is equal to E minus IR, and I can also take the small v in this case to be substituted as I into small r.